There's some really good stuff here in this 3.6. Ready, set, go. What is this? Yeah. Connecting zeros to the solution. Okay, so I have told you before that like we use vocab interchangeably. Like we say zeros, solutions, x-intercepts. And a few of you on your quiz when we were solving the quadratic, you got 0 on one side, but then you told me the answer as a x-intercept. That's not quite right. If they're asking for a solution, you need to say x equals, or if they ask you for the 0, you could say x equals. X-intercepts are the only time we usually do the ordered pairs, but it is interchangeable vocab, and I was glad that you guys remembered that. So what they're doing here is they're giving you the graph, and they're asking you to find the zeros. Now, because they're giving you the graph, actually you don't have to do any math here, because zeros are when this is a line. When does the line equal 0? The line equals 0 right here at this point. The answer is -6. Now, if you want, you can math it out. 0 equals 2/3 x plus 4, and then you subtract 4. -4 is 2/3 x, and then multiply by the reciprocal 3/2. -12/2 is -6. But why? If they give you the graph, why would I do that? So you can use the graph to find the solutions when this line equals 0. Okay, because as it is, there's infinitely many solutions. This is talking about the graph of a line. When they ask you to find the zeros, that means to replace the f of x with 0 and find that point that looks like the x-intercept. So they want you to mark it. They want you to just look at the graph, I think. So I did show work on all of my stuff in case somebody did it the long way, but you don't have to. Okay, so here's the line. Where does g of x equal 0? Well, that would be the x-intercept. Once again, it's at -6. X is -6 is a solution to this equation when it equals 0. 2x minus 6, here it is. Oh, look at that. They didn't quite mark it. You could solve it if you want, but the scale is 1s. It looks like the answer is x equals 3 is the 0. What happens here, first of all, it's harder to see what's happening here. It's right there. Looks like there are 2 zeros because there are 2 locations that will make p of x equals 0. There are 2 x-intercepts. Doggers, what do we got here? Where the scale is, I hate how they keep changing the scales from each of these. Looks like -1 and 3. Now, just a refresher, because this one was actually similar to the one on our quiz. If this was to equal 0, you could factor out a GCF first, x squared minus 2x minus 3. You could divide both sides by 5 if you want, or you could just continue to factor x minus 3, x plus 1. The answers are 3 and -1, just like we said. X equals 3, x equals -1. There are 2 x-intercepts. Same thing here. One of them is at 0 and one of them is at 5. If you pulled out the GCF here, it would be x minus 5. This guy, if 4x was equal 0, it would be at 0. This one has 2 as well at 3. Yeah, -3. Some of you would have a hard time factoring this. You would probably do quadratic formula, but if you change this to 9 minus x squared, then it's the difference of 2 squares, 3 minus x, 3 plus x, and the answers are plus and minus 3. Plus and minus 3. Okay, so that's what they wanted you to do at the top. In this middle section, it was easier than the notes. They just want to know if it's always, sometimes, or never. If it's sometimes, give when it works, and when it doesn't. And if it's never true, give a counterexample. Okay? Product of a whole number and a whole number is an integer. If you have a whole number and a whole number, I wonder what I posted for this. You get a whole number, which a whole number is an integer. I'm doubting myself. I'm looking for my answers. Hold on. I did it right. It is an integer. A whole number and a whole number, when you multiply them together, you actually get a whole number. But all whole numbers are integers, so that is actually always true. You don't have to explain the always, it says. Okay, the quotient of a whole number divided by a whole number is a whole number. That is a sometimes. It's a sometimes. Because you could have 12 over 3, and that's 4, which is a whole number. But if you have 3 over 12, that's 1/4, which is not a whole number. The set of integers is closed. The idea of closed, if you remember, is so if you divide two integers, you always get an integer. So that is not true. I really should have pulled these answers out because I feel like I don't feel like things should sometimes be closed. I left it all the way across on my table. Yeah. Okay. So I did write sometimes, and that's good. So sometimes it's sometimes closed for the reason we just said. You could use the same thing again. 12 over 3 is 4. Those are integers. 3 over 12 is 1/4. Those are not. The difference of a linear function and a linear function is an integer. Sometimes it's a integer if the linear term crosses out. So if I have 2x plus 1 and then I have a negative 2x plus 3 and I add those, what am I doing? Difference? So I'm going to make this negative 2. And I subtract these two, I would subtract all the pieces. Some of you didn't do that on your quiz. That's a plus 2x and a minus 3. So now those two x's cancel out and I'm left with negative 2. That is an integer. But if this was, let's say it was 4x, negative 4x plus 1 and negative 2x plus 3, and I subtract them, and that's a plus and that's a negative, then I get negative 2x minus 2, which is a line still. So that's just a sometimes. The difference of a linear function, a quadratic, is a linear. That is not true. You will still have a quadratic function. They really didn't give you much space there. That was kind of a jerk of them. I'm sorry that happened. That is not true. Because if I take a quadratic, let's say I have x squared plus 1 and I subtract x plus 3, subtract all the pieces. So I get x squared minus x minus 2, which is still quadratic. You're always going to get a quadratic on those. If you multiply two lines, do you get a quadratic? Yeah, you do. That's always. If you add a quadratic and a quadratic, do you still get a polynomial? Yes, we talked about it yesterday. Polynomials are closed under addition. If you multiply a line and a quadratic, do you get a cubic? That is also true. Because if you take something squared and you multiply it by something with the degree 1, you'll get a degree 3. If you multiply 3 lines, do you get a cubic? Yes, you do. That is always true. And I just answered the question for this. Polynomial functions is closed under addition. That is always true. Every time you add polynomials, you'll get a polynomial. Even if they're kind of opposite, you'll still get that constant. Okay, conjugate pairs. This is super important, and there's a lot of writing here, and I wish that there wasn't so much. Very important because mathematical things happen. Remember, the first number is the same, the second one is different. Difference of two squares are conjugate pairs because there's no middle term. And when we do the quadratic formula, we always get quadratic. We get conjugate pairs. And this is really important because if you have imaginary solutions or irrationals, irrational numbers and imaginary numbers always comes in pairs, conjugate pairs. They never come alone. So if I tell you that one of the answers is 3 plus root 2, you know 3 minus root 2 has to be 1. Same thing with the imaginaries. Okay, they have to come in pairs. This whole bottom is super easy then, and I'm afraid a lot of you skipped that reading because of it. You just have to change the second sign to tell me what the conjugate pairs are. So this is just 8 minus square root of 5. If this is a solution, this is a solution. If 2 minus 13i is a solution, 2 plus 13i is a solution. If 9i is a solution, negative 9i is a solution. If negative 5 root 7 is a solution, positive 5 root 7. So all of these, you just have to change the sign of the second term to make it the conjugate pair. And they always come up using quadratic formula together. Okay, that's it for the notes. Enjoy your weekend.